welcome. This is 8.3. Okay, 8.3 is a really easy section, so I'm going to do a little bit of review type stuff to talk about what we did in previous sections, notably the most previous section. So in the last section, we had y equals a times x minus h squared plus k, and this was called vertex form. If you're here for the live stream, we talked about this in detail, or you can go back and check it. I have it linked on my homework calendar. But h comma k is the vertex. If you're like, man, I don't even remember what a vertex is. Here's what a vertex is. If you have a parabola, which look like U's, a quadratic graph, then the bottom point, the spot where it turns around, that's the vertex. So any sort of parabola, the vertex is this top or the bottom, the spot where it turns around, goes from going up to going down. That's always our vertex. And our vertex is always at h comma k if we're in vertex form. So it's always the opposite of what's next to x and the y. So same as point slope form for that feature. Notice the squared here, that's what makes it a quadratic, that's what makes it a U-shaped graph like this. And the last piece is we have this A thing, and this A thing we call a vertical stretch or shrink. Stretch or compress. People use a lot of different words for these. Shrink or compress are synonyms. They mean the same thing for this. And stretch is the most common word used for this, but dilation is another word. And these are just a bunch of different words that all describe the same thing. The big idea is it's the steepness. If I make A bigger, then my graph is going to go up more and more. If I make A smaller, my graph's going to be wider, like so. And so for a graph to be wider, usually the A is between 0 and 1. And if I want my graph to be really steep, my A is just going to be greater than 1. All right, that's vertex form in a nutshell. The reason I wanted to go over that is we are going to be converting from vertex form to another form. And then looking at what that form does. So if I have a vertex form equation, like y equals 2 times parentheses x plus 4 squared plus 3. This is a vertex form equation. I can tell the vertex is at negative 4 comma 3. I know my steepness is 2, but I'm going to be converting this to standard form instead of doing any sort of like graphing or anything like that. All I'm going to do is distribute the 2. Wait, no, I can't do that. That's illegal because there's the squared here. And in order of operations, exponents come first. So I actually have to do x plus 4 squared, which if you remember back to last unit, means I have to do a box or FOIL. And if I do the box, I get all these parts, which means I'm going to get y equals 2 times parentheses x squared plus 8x plus 16 plus 3. Now I can distribute that 2 because there's no exponent left, so in order of operations, m comes next before a addition. And I get y equals 2x squared plus 16x plus 32 plus 3. Last step, I need this 32 and 3 to go together. So I get y equals 2x squared plus 16x plus 35. This is standard form. These two parabolas have exactly the same picture. They are exactly the same parabola. The difference is one of these forms tells us where the vertex is. That's vertex form. And in standard form, we actually get something different. This last number is all we really care about in standard form. And in standard form, this last number tells us the Y-intercept. Now here's the good news. Converting from vertex form to standard form isn't something I'm going to be asking you to do as an assignment now. This is actually going to be part of next unit and is deemed too hard to be on this particular unit. All you're going to be doing this unit and for this section is you're going to be given a standard form equation. So it's just going to look something like x squared plus 4x minus 15. And they're going to ask you, what is the y-intercept? And all you're going to do is you're going to look at the last number here. And then because the y-intercept is an x-coordinate and a y-coordinate, we have to give a ordered pair. We're just going to do 0, negative 15. The reason why we're always going to do 0 for our first term is because the y-intercept is always when x equals 0. Like the y-intercept is where we go through this line right here. And that is always going to be when x equals 0. So in this case, we're like 0, negative 15, something like this picture. So let's try that again. If I have y equals negative x squared plus 3x plus 7, all I'd say is my y-intercept is 0, 7. Yeah, there isn't a lot more to this. In this case, if I wanted to make a really crummy sketch of my picture, I'd know 0, 7 is my y-intercept, and I'd also know this is an upside down parabola because it has a negative in front of the x squared, so it looks something like this. Sweet. Let's try one more. Y equals 4x squared minus 13x plus 2. Well, my y-intercept only uses that last term, and it's 0, 2. All right, folks, there isn't much more today. Standard form, all we look for is this last term. In vertex form, we had a bunch of things. We cared about the vertex, we cared about the steepness, we go back and forth. In standard form, all we care about is that this last piece is the y-intercept. That a lot of that stuff is still here. This is the steepness, this 4. And we could factor this in some way, which we're going to get to next unit, that would help us find our vertex. But admittedly, in this section, when we're given standard form, we don't care about where the vertex is. All we care about is reading where the y-intercept is, which is at 0, 4 in this equation. It's literally just look at the number at the end and do 0, that. And that's it for the online homework. I'll be assigning that now, and yeah, good luck with that. It shouldn't take you too long if you understood the general idea of this. All right. See you again on Wednesday.